Next we are going to explain refraction of light. In previous lecture I have explained the reflection of light by the help of Huygens principle. Here we are going to explain refraction. See here, let us consider a plane wavefront. Again we have taken a plane wavefront AB. This is the plane wavefront AB. The direction of ray is perpendicular to this plane wavefront. So this is the direction of ray. Perpendicular to plane wavefront, incident at an angle I. Angle of incidence, here if you will see, this angle is I. Angle of incidence, this is the normal here. I with the normal to plane boundary MN separating two uniform, and this is the MN boundary. Here one medium, here medium 2. So boundary MN separating two uniform and optically transparent medium 1 and 2. So this is the boundary of the two medium 1 and 2. 1 AB I have taken a plane wavefront. So you can draw here this plane wavefront A dash, B dash, A dash, B dash, then it will come. When this plane wavefront touching the boundary surface, the first touching point of the plane wavefront at point A. Incident wavefront AB touches the boundary surface at A at t is equal to 0. This time I have taken t is equal to 0. And point B will touch the boundary at t is equal to t. Mean after time capital T, this will touch the boundary surface. Point B will touch the boundary surface. So there are two medium, 1 and 2. One thing more I have assumed, velocity of light in first medium is V1. Velocity of light in second medium I have taken V2. Speed of light be V1 in medium 1 and V2 in medium 2. By Huygens principle, ध्यान से देखिए, by Huygens principle what they have said, the point on AB they will behave like a new source. So if A will behave like a new source, then what happen? It creates wavelets. What will be the radius of wavelets? See here, B will reach at this point. Suppose this I have taken C. So B will reach at C after time t. V1 will be the velocity. So what will be the BC? BC is equal to what? BC is equal to velocity V1 time t. So BC is equal to what? V1t. The value of BC will be V1t. See here, in time t, what will be the radius of wavelets emitted from source A? The radius of hemispherical wavelet, is equal to what? This radius is equal to, here you will see, in previous lecture we have seen there are reflecting surface. Here this is transparent medium. So light will pass through this medium. Velocity of light here V2. So in time t, what will be the distance traveled by the by the light in this medium? So that will be V2t. The radius of wavelets emitted from A will be V2t. So see here, each and every point between A and B, they will reach at the surface AC and they will refract here. So what will be the other points? Radius of hemispherical wavelets. So they will lie from from V2t to 0. Their radius will be lie. So if we will draw a hemispherical wavelets. So here I am drawing hemispherical wavelets. This suppose I have drawn a like that, it will be hemispherical wavelets. of radius V2T. So touching surface from here to here and reflected wavelets from AB. If we draw from C touching surface, so this will be the touching surface. So this touching surface will represent new wavefront. And if we'll join perpendicular line from here, again if we'll trace here and perpendicular to, so this will be the direction of waves, direction of ray. This point I have taken suppose D. So this length AD is equal to V2T. So see here AD is equal to V2T, BC is equal to what? I have found it. This is equal to V1T, and perpendicular to CD. Again they will form new wavelets. Again if you will see, so next wavefront, again next wavefront. So this will be the direction of ray. So see here, this is the incident ray. And this is the reflected ray. If we draw here, so this is angle of reflection. ये angle of incidence, suppose I have given a name N dash N double dash. So angle A dash A N dash, angle A dash A N dash will be angle of incidence, and angle N double dash A D, this will be the angle of reflection. The angle of incidence, this is the angle of reflection. See here, this is perpendicular to this. Total angle is 90 degree. So what will be this angle from here to here? The total is 90 because ray is perpendicular to wavefront. So total angle is 90. This is I. So this is what? 90 minus I. And also N dash A perpendicular to this AC. So total 90. So 90 minus I. So this angle is I. So see here from the figure. From figure, what you will see, A dash A perpendicular to AB. That's why angle N dash AB is equal to what? 90 minus I. And N dash is normal. N dash A normal to the surface AC. Total angle is 90, so this angle becomes BAC is equal to I. So angle BAC becomes I. Same way, if you'll go here, this is R, so this angle is what? From here to here, if you'll see, so this angle becomes 90 minus R. Angle DAC. Angle DAC is equal to what? 90 minus R. So see, this is perpendicular, this is 90, this is 90. So this 90 minus R, so this angle becomes R. Angle ACD becomes R. So see, if you see these two triangles, ABC and ADC. If you see these two triangles, what you'll see? Sin I in triangle ABC, right angle triangle, sin I is equal to what? Sin I is equal to what? Perpendicular upon hypotenuse. So perpendicular mean BC upon hypotenuse is AC. And BC, what we have found it? BC is equal to what? V1T upon AC. This I have given in question 1. Downward triangle and triangle ADC I have taken sin R. What is sin R? Sin R is equal to what? Here you will see perpendicular AD upon AC and AD length. This is radius of hemispherical wavelet. So that is V2T upon AC. So from 1 and 2, what you will see, sin I upon sin R is equal to V1t divided by AC, V2t divided by AC, AC, TT cancel, V1 upon V2. So sin I upon sin R is equal to what? V1 upon V2. See here, if you will divide it by C, this can be written as in the form of C upon V2. Here we can write C upon V1 in the terms of speed of light. So this C multiply up and down. So C upon V2 divided by C upon V1. So C upon V2 is what? Refractive index. Absolute refractive index of medium 2 divided by absolute refractive index of medium 1. So this sin I upon sin R is equal to N2 upon N1. This is the Snell's law, yeah, you can say this is the laws of reflection. Laws of refraction. See here, by the help of Huygens wavefront, by the help of Huygens principle, what I have proved, sin I upon sin R is equal to N2 upon N1, or you can say refractive index of second medium with respect to first medium. तो यही आपका कौन सा लॉ था बेटा? Laws of refraction. And one thing more, see here, incident ray, normal and refracted ray all lies in the plane of paper, or you can say plane of board. तो all lies in the same plane. तो फर्स्ट आपका प्रिंसिपल क्या था, फर्स्ट सारी लॉज ऑफ रिफ्रैक्शन क्या था कि इंसिडेंट रे, रिफ्रैक्टेड रे, नॉर्मल एट द पॉइंट ऑफ इंसिडेंट ऑल लाइज इन द सेम प्लेन. वो भी यहाँ पर आपने देखा हाइजेन के प्रिंसिपल से प्रूफ हुआ. और दूसरा, द रेशियो ऑफ साइन ऑफ एंगल ऑफ इंसिडेंस टू रेशियो ऑफ साइन ऑफ रिफ्रैक्टिंग एंगल फॉर ए गिवन पेयर ऑफ मीडियम इज ऑलवेज कॉन्स्टेंट. तो वो भी हमने देखा, एंड दैट कांस्टेंट इज कॉल्ड रिफ्रैक्टिव इंडेक्स ऑफ सेकंड मीडियम विद रिस्पेक्ट टू फर्स्ट मीडियम. तो दोनों चीज़ें यहाँ पर प्रूफ हुई. अच्छा, एक थोड़ा सा स्पेशल चीज़ें यहाँ पर हम और भी ध्यान से देख सकते हैं. हमने लॉज ऑफ हमने रिफ्लेक्शन में देखा कि दे आर लेटरली इन्वर्टेड. क्यों? क्योंकि हमने क्या देखा था बेटा, जब लेफ्ट ए था इंसिडेंट में, राइट बी था, तो वो कन्वर्ट हो गया. ए का जो है लेफ्ट का राइट, राइट का लेफ्ट. बट इफ यू सी हियर, ए बी इज इंसिडेंट, ए बी इज इंसिडेंट एंड देयर रिफ्लेक्टेड इज डी सी. See here, this is initial wave front, this is refracted. They will lie in same. If you see, A right, A will reach at D, B will reach at C. So A in right hand side and B left. So A will reach D, so D also right and C. So here there is not lateral inversion. यहाँ पर lateral inversion नहीं होता. सिर्फ क्या होता है बेटा, speed of light decreases. Why? Because here if you'll see, the velocity of, or you can say the radius of wavelets will decrease. That's why if we will move from rarer to denser, what happen, wavelength will decrease. Wavelength decrease करेगा, or you can say velocity of light decrease करेगी. एक चीज और भी कह सकते हैं कि if we'll see that will turn along the normal. So you can say also if we incident ray moves, या लाइट मूव फ्रॉम वन मीडियम टू अनदर डेंसर मीडियम, ऑप्टिकली डेंसर, तो लाइट विल टर्न, और लाइट विल टर्न अलोंग द नॉर्मल. तो ये सभी चीज़ें उन्होंने क्या है अपने हाइजेन प्रिंसिपल से शो की. ठीक है कि इंसिडेंट रे, नॉर्मल, रिफ्लेक्टेड रे ऑल लाइज इन सेम प्लेन, एंड रेशियो ऑफ साइन ऑफ इंसिडेंट एंगल टू साइन ऑफ रिफ्रैक्टेड एंगल फॉर ए गिवन पेयर ऑफ मीडियम इज ऑलवेज कांस्टेंट. That constant is known as refractive index.